Today we'll be working on lesson 5.8 using logs to solve exponential equations. But before we start on our practice sheet, I'd like to review the concept of changing from exponential to logarithmic form. So if I give you this example, 2 to the power 3 equals 8. I want you to remember that we call this a base, we call the power exponent, and we call 8 an argument. So if I want to change from this exponential to a logarithmic form, what I do is the following. Since the base is 2, so I write a subscript to be 2. The argument 8 becomes a number inside the log, and the exponent 3 will be the answer of my log. So remember, base goes as a subscript, the argument goes inside the log, and the exponent is the answer of the log, because when they ask you to find the log, they're basically asking you to find a specific exponent. Okay? So if you remember this, then this practice sheet is going to be super easy. Let's start with number 1. As you can see, this is an exponential function or equation, and the exponent is x. This is the variable. So in order to be able to solve this exponential function, I have to change it to a log form. So the base 5 becomes the subscript, and 10, the argument 10, becomes a number inside the log, and the answer of this log is going to be my exponent. So x is equal to log 10 base 5. Now this is not something that you can do mentally, so we have to use the calculator to find it. To do that, you go to math, you go up a little bit until you get to log base, you press enter, and then you put the subscript to be 5, the argument to be 10, and then the answer would be x. Always round to the nearest thousandth unless you are asked otherwise, okay? So 1.31. Now, if the base or log base is disabled on your calculator, what you can do is you can do the change of base formula and change log 10 base 5 to log 10, the argument, over log of the base, which is 5. By using the change of base formula, I can do that. And then if you find log 10, don't forget to close parentheses, divided by log of the base, which is 5 in this case, you're going to see you're going to get the same answer. So if the log base is disabled, make sure that you use this method. Now let's move on to number 2. And again, as you can see, the variable is in my exponent. The best way to solve this is to change it to log form. So again, the base 1.3 becomes a subscript. The argument 78 is a number inside the log, and this is going to be equal to 2x. Now, I do recommend that you use the calculator as a last step. So as you can see here, 2x is equal to log of 78 base 1.3. But you need x, so you need to get rid of the 2 by dividing both sides by 2. So then x in this case is equal to whatever log of 78 base 1.3 is divided by 2. So let's find that. You can go to math and then to log base. Find out what this is equal to. And then this would be it, and then you divide by 2, because x is going to be whatever that is divided by 2. And remember, keep rounding as a last step. Round to the nearest thousand, so that's going to be 8.303. Okay? Now again, if your log base is disabled, you find the log of the argument, which is 78 in this case, divided by log of the base, log 1.3. And then you divide that by 2, and you're going to see you're going to get the same answer. So let's move on now to number 3. Now I do like this example because I want to show you how to do it without a calculator first, and then we'll use a calculator to solve it. And the reason why I know I can solve it mentally, because 16 can be written as a 2 to a power of something, and 16 is 2 to the power of 4, right? Now, if you can change both sides to be the same base, then it can be solved algebraically, okay? So you can write 16 as 2 to the power 4, and don't forget to copy 3 plus x as the exponent is equal to 2. Remember that power to a power, you multiply, so it's going to be 2 to the power 4 times 3 plus x. Now remember, if it's 2, it means it's 2 to the power 1. Now, as you can see, we have the same base, so my exponents are going to be equal to each other. Now, if you distribute the 4, you're going to get 12 plus 4x equals 1. I don't know why I added an x over here. Sorry for that. So 4 times 3 is a 12. 4 times x is 4x equals 1. Since if it's a 2, it means it's 2 to the power 1. Now remember, you want to find x, so isolate x. 1 minus 12 is negative 11. You need x, so divide both sides by 4. So x is equal to negative 11 over 4, or whatever that is. Let's find it. So my final answer is going to be negative 2.75. Now this is how you do it algebraically. Now let's see how we can do it by changing. Like, see how we solved it and we kept it in exponential form? Because 16 was, we were able to change 16 to a 2 base of, to a 2 to the power of something. But you can still solve it by changing it to a log form. So this is what we're going to do. We're going to use a different method. Now remember that as you can see, the base is 16, so it goes as a subscript. And the argument is 2, so it goes inside the log. So log of 2 base 16 is equal to 3 plus x. Now remember, to find x, you need to isolate the x. So subtract 3 from both sides. So x is equal log of 2 base 16 minus 3. So let's find that. And it should be the same answer as we found before. And we're going to put, again, if log base is not working, you can do log of 2 over log of 16. As you can see, we got the same answer. So you can either keep it as exponential and solve it algebraically, or you can change it to log form and solve it as well. So now let's move on to number 6. Okay. Now, in this problem, remember that, as you can see, it's not in exponential form. Okay? You need to isolate the x to be able to change it to log form. So remember, it has to be a base to a power of something to be able to change it to log form. It is exponential, but we need to be isolating this part where the base is 4 and the exponent is x. So this has to be by itself on one side of the equation. We have to get rid of the 5 and the negative 3 to be able to change it to log form. To do that, you add 3 to both sides. So basically, first of all, add or subtract whatever number you have next to the x, okay? So now we have 5 base 4 to the power x is equal to 13 plus 3 is a 16. Now, as you can see, the 4 is not isolated. The x is not isolated yet, so you need to get rid of the 5. You do that by dividing both sides by 5. So now 4 to the power x is equal to 16 divided by 5. Now this is something I can change to a log form, okay? Now as you can see, the exponent is x, so I need to change it to log to find the x. Now the base is 4, and the argument is 16 over 5, and this is going to be equal to x, okay? This is how you change it. So remember, you are only able to change to a log form if your exponential part, the one with the power x, is isolated. Now in all the previous examples, the base was isolated. You see that? 16 to the power 3 plus x. So 16 was isolated. Let's move on and see the other example. As you can see, the base and the power were by itself. Now, and number 1 also, the base and the exponent by itself. Now 16 is our first example where we have to isolate to be able to change to log form. So now after we did that, again we can go to math, log base. Now this is going to be 4 And in here, you can write 16 divided by 5 or 16 over 5. Or you can create a fraction. Remember to do that, you can do alpha y equals and then enter. Now, press enter, and that's going to be your x. So as you can see, x is equal 0.839, okay? Now let's move on to the back of this page, and we're going to be doing number 9 and 10. So let's move on to number 9. Now as you can see, the one having the power is not isolated. We need to isolate this to be able to change it to log form, okay? Now to do that, you add 3 to both sides. So get rid of the negative 3 first, okay? 12 plus 3 is 15. Then you need to divide both sides by 14. This way, the one with the power is isolated. Now, you can change it to log form. So it's going to be log base 2 of 15 over 14 equals to 2x, okay? But still, you need to isolate x to find it. So you need to divide both sides by 2. So x is equal to log, whatever log base 2, 15 over 14 divided by 2 is equal to, okay? So let's find that. Now I'm gonna use the change of base formula, and I want to also show you how, let me clear that. I want to also show you how to do the alpha y equals, just to change as a change. Okay, so log, and you put alpha y equals. To create a fraction, you press enter, and then this is going to be 15 over 14, okay? You need to move over to create a bigger parentheses, and this is going to be divided by log of 2, okay? So I use the change of base formula, log of the argument divided by log of the base. Press enter, and then whatever answer you have to divide it by 2. Okay? Now, so as you can see, my final answer is going to be 0.049, which is basically 9 has to go up because we have a 7 next to the 9, so 0.0497. Since this is a number greater than 5, we're going to increase 9 by 1, so it's going to be 0.05. Okay, now let's move on to number 10. Now, as you can see, the one having the base is isolated, the one with the power is isolated, 4 to the power 2x plus 1. There's nothing added or nothing being multiplied. So I can directly change it to a log form. Log base 4 of 671 is equal to the power, which is in this case 2x plus 1. Now remember, I would like you to use the calculator as a last step. I don't want you to be finding this and rounding either up or down. So I don't want you to estimate from here. I want you to estimate as a last step. So to find x, keep this as it is now. Do not find what this is, because I want you to leave estimation as a last step. So subtract 1 first. Okay, so it's going to be what? Log 671. Base 4 minus 1 equals 2x, okay? And then you need to divide everything by 2, okay? Now remember that this 4 goes with the log, okay? So everything is divided by 2. Now to do that, go to math, log base, 4 and 671, okay? Minus 1, find that, and then divide it by 2. As you can see, I'm not estimating, I'm not rounding just yet. Let it be the last step. So it's going to be 1.848. Okay, now this is everything for 5-8. I hope that this tutorial was helpful.